The technology which is there for mining, the technology which is there for breaking, generating those hash codes in the bitcoins, you know, that is being used to give you the blockchain. Okay, it's a consensus mechanism which gives you a consensus between different parties altogether to tell you that this is the blockchain. Okay, I'll try and show you a video first, and then tell you what a blockchain is all about. Can you see my video screen, Dr. Jan?
Sir, yes, you once.
Yeah. Yeah.
Audio is missing, sir.
Audio is missing. Just one second.
Yes, sir. Please.
Coming now?
No, sir, audio. Sir, you can explain the audio at later on.
Okay.
You can see
Okay.
the video.
Okay. So I will just tell you that you see this flock of birds which is flying all across, and just imagine these birds, they never hit into each other, right? And just see, there's so many in number, and not a single bird touches their wings to don't touch, the way they are flying, right? And uh, and so many of them. And if you analyze this analogy to the blockchain, these are your nodes, these are your ledgers, and none of the nodes or ledgers practically, right, are kind of touching each other. It's all immutable. It's giving so much of transparency, right? And they're all spread all across the world, right? And still they're able to work in a very synchronized manner, right? And this bird's example is a very rightful example when we say a blockchain. And it's all between, some people say the birds are too smart, they have AI in between, that's why they don't collide. But just see how they are flying. And none of them is, hitting into each other. And if one bird hits each other, the complete chain will break, right? So the analogy between the block and the chain is, there are the blocks and the chain which gets created, right, is the way the blockchain works. Okay? Right. So this is the example actually of a blockchain where none of the nodes which are there, they can have a duplicate entries into it. They cannot have, kind of data which can be manipulated. And blockchain practically gives a very high level of, security per se. And when I say blockchain, so I just want to bring out, that's what I was trying to say, that I'll just go on to other slide and tell you where was the origin of blockchain, how it came into being, and what it all entails, right? And everybody has heard the terminology called Bitcoin or a cryptocurrency. Okay? And when we say the cryptocurrency, this came first time by a concept note written by a person called Satoshi Nakamoto. This guy was, we still don't know who this person is all about. Okay? And the first open source software was being created in 2009, and in August, I think the first coin was mined, and that was $1. Was a one Bitcoin. Today we are having a Bitcoins which are almost 10,000. dollars. Okay, and all the payments are recorded in public. Now you understand that today in the banking system, anything transactions, whatever you're doing, they're recorded centrally, right? They're recorded in a ledger, but nobody knows that ledger. Here you are recording all the readings or the recordings in a public ledger, which are linked and they are stored in blockchain. So underlying technology between the blockchain and the Bitcoin is blockchain is underlying technology. Bitcoin is what we are seeing today, and that's what is being traded in the market as a cryptocurrency. Okay, and I'll come to those concepts as well. It's a form of a digital currency. The physical form is absent, and they can be held electronically, created electronically. I'll just show you very quickly as to how they get created so that it will give you a very idea as to what's happening all about. Okay, and they can be traded, right? And it is no different than a conventional dollar. So there are almost 70 countries who have made this cryptocurrency very public. They have made this as a legal tender, and they're using it. And there, it's also being known as cryptocurrency, and there are almost 6,000 varieties of cryptocurrencies in the market today, right? And sometimes they're called, as a BTC, and it's almost 8 million times. Like you and a rupee, you cannot break a rupee beyond 100 times. Here you can break it to point eight zeros times that particular Bitcoin. So it's a very granular. So what are the properties of Bitcoin? It's open because the technology is pretty open. How Bitcoin practically coming is, there's an algorithm which using the computing power, you break the code, right, between the private and the public key, using the crypto algorithm. Okay, I'll just put that. Now it's okay, Dr. Vishal? Right. So, let's say public and a private key. So, whosoever break those codes first, he is being rewarded by this Bitcoin. So, anybody anywhere in the world with the computing power, with the knowledge of the cryptography, can be part of it to generate those bitcoins. So they're open, they're fast. They're fast means they're almost 12.5 bitcoins, which are generated every 10 minutes. It's permissionless. There's no permission. There's no central body which is binding any Bitcoin cryptocurrency. It's pseudonymous. Like why it's pseudonymous? Because it has a capability of being anonymous, but then there are features because of the pseudonymous. We can find out who is the holder of that Bitcoin. Where was the Bitcoin being mined? It's been secured by the cryptography. There's a 34-bit hash key which was generated, and we are using different algorithms to generate those hash keys, right? And they are recorded in a public blockchain. So whatever you're doing, so say for example, there are nodes today. There are almost 7 to 8,000 nodes all across the world. So it gets recorded in all those nodes, that particular information. So if you have a particular node with you, so you'll have all the transactions of everyone in your node. It's fungible, but it's doubtful. It's global, so there's no boundaries. It's decentralized, so there's no central body which can control cryptocurrency today. It's peer to peer, right? It's volatile. The prices go up and down because it's been traded and it's demand supply based. It's divisible, like I told you one of millionth. You can have this divisibility too. It's trustless. So each node, for example, is trustless. So the birds what you saw, right? They were trustless. Yeah, there were no trust in between them, but they were all still flying. Similarly, are the nodes. They are trustless. But then they're all communicating to each other. They're updating their data in the ledger, right? Then there is no intermediary. and it's not controlled by anyone. But the defining factor in the Bitcoin is that the paper which was written by Satoshi Nakamoto, right? It said only 21 million bitcoins can be mined till 2140. Okay, but we are all of us are very crazy people, so we have already mined 18 million, and plus there are all n number of bitcoins have come all across. They're all trading. That's there. I'll just show you quickly that also, and they're all limited supply. When there are limited supply, that means there is demand supply. So today it's around $8,400. Yesterday it was $10,000. In the month of December 2017, it went almost, it was 17 or 18, I think 18. It went up to $18,000. So it's highly volatile, right? Right. So this is the kind of a timeline how the Bitcoin has emerged. Nakamoto began working on the paper. Nobody knows whether it's a group of people, whether it's an individual. Bitcoin.org was registered in 2008. 2008 white paper was published for crypto mailing list. January 1st, Genesis block was mined. So Genesis block is the first block in the complete Bitcoin. So that is the first time they had mined. January 9, 2009 was a code what they had posted, and then transactions started happening. And on 5th of October, that's what I was trying to tell you. The exchange rate of one Bitcoin was, one USD was almost 3,100 Bitcoins. Okay, and thereafter the mining tools came up, and a lot of people have started mining into it. It's become a business, and I'll just show you how this is growing and why knowing about a Bitcoin is so important for you to understand what is a blockchain. Otherwise, it won't be like the right to talk of a blockchain if you don't understand the Bitcoins altogether. So that's what I brought in. They are not regulated. They're decentralized. They take advantage of cryptography or mathematical approach to provide safety of transactions. Okay, and presently they are not regulated by anyone, and they are generally capped with a limited release. Okay, and the number of bitcoins which are there, I'll just show it to you how the Bitcoin is there. I'll just move to that slide quickly. Then there's something very interesting. 12th of May, we had the Bitcoin halving. Half valuation was done on 12th of May. So whatever was in the Bitcoins which were there, the portion was getting half of the actual value. So it's a deflation, and the reward is cut to half every 4 years, and it happened only yesterday. That's 12th of May, and the tokens can be irrevocably destroyed, and it can be have a fragmentation up to 8 decimal places, and they cannot be double spent. They cannot add. You cannot add coins arbitrarily. They're consensus driven. Like the birds which are there. Same example. They're all consensus. If you have a consensus between different ledger holders or different nodes, then only the things will happen. Okay, and otherwise it won't happen. Okay? And this is the advantage what you get practically when we talk of you having the capability of the cybersecurity. And it's told that if you control 51% of your node, then only you can bring down the blockchain. Otherwise, you cannot bring down the blockchain altogether. And it's non-reputation. There's no recourse, and no one can appeal to return a cent tokens, right? So that again is advantage of this. Who are the players in it? They are miners. These are people who mine the bitcoins, and mine is basically it's just the kind of like it's a gold mine. Similarly, you have the algorithm, and you have the private and the public key, which is there. And if you are able to break that code, you are being rewarded. So that is called a proof of work. And the proof of stake is the stakeholders who are there in that mining. Okay, and it follows your consensus mechanic. There are the users who are using their Bitcoin, and then is the merchant, because you can buy a Starbucks coffee in Canada today. In Switzerland, you can use the Bitcoin for your transactions, even all the government transactions which are happening, like your birth certificate, death certificate, your other government forms, you can pay through your bitcoins, right, in Switzerland. Similarly, there's a country called Malta. That's again totally a Bitcoin savvy country. Everything is on Bitcoin. Estonia is a Bitcoin. So there are a number of countries who are really going for Bitcoin. And where are they storing? They are stored in wallets, like your Paytm wallets, what you have, your e-wallets, and you have exchanges where you trade them. Okay, and this is what it is. There are almost 18.23 billion bitcoins which have been traded so far. They are in circulation. The total maximum what they can be mined is around 21 million, and this has come down from 25 new bitcoins. It's just come down to 12.5 bitcoins because the degree of difficulty is very high. Okay. Now I will just run on to the kind of slide where I'll just show you. This is the kind of the depictions of different bitcoins of different cryptocurrencies all across the world, right? And there are a huge number of cryptocurrencies which are existing today, namely Bitcoin, Bitcoin Cash, Ripple, Ethereum, Newcoin, Monero, BitShare, Namecoin, Litecoin, Altcoin, number of them which are there today, and they have been traded on different exchanges, right? And I will then touch on. Wait a second. This is the kind of the Bitcoin address, the public key addresses which are there. Okay, this is practically your key which you get, and this is your your Bitcoin value, your cryptocurrency value, and it has been generated through the elliptic curve cryptography, right? And you can utilize it through your e-wallets, right? This is how different Bitcoins have been mined all over the world. Europe is quite active. This part of the world, that's Korea, Japan, and other countries, China, they're very active. Australia, then North America, South America, India too. There are nodes which are existing, right? This is the heat map of the same thing. There are almost 15,048, nodes. This has gone to almost 17,000 nodes as of now. In India also there are mining, and it's all happening in India as well. While in India it's being told as it's illegal tender, right? And you must be thinking how you can mine a Bitcoin. And this is the Bitcoin mining data center, a small one, right? Where you're using the ASCII cards to mine the Bitcoin. Okay, that's a graphic cards. What because they have very high computing power compared to your normal, cards. So ASCII cards are the ones which are very much in demand today. They are being used for mining the Bitcoin. Okay, and here is the one. I'll just show you one more. Yeah, this is the kind of people with kind of a rudimentary skills. They want to do a Bitcoin in the house. They can create a jig for all the Bitcoins for the mining and using all the cards, right? And the professionally what they do. This is one of the cards which are being used for the Bitcoins today very aggressively. Okay, and this is how the data centers look like. This is in Russia, where they're only mining the Bitcoins. Okay, and just see the amount of uh, you know, ASCII cards devices which are being integrated, and they have a wall of 100 megawatt mining facility with them. Right. This is again Bitcoin mining somewhere in China, okay, in the colder parts of China. This is another Bitcoin mining data center, right? This somewhere in Iceland, okay, and this is the Venezuela. So you just imagine this is all happening. This is again China, and they're very secretive about it. They don't let anybody get into how to mine. and where they are trading this. It's being traded on different exchanges. Like we have the National Stock Exchange and the Bombay Stock Exchange, where you're trading your, all your stocks. Similarly, these are the exchanges, right? They're almost 1,200 in number, right? Where you can trade all your bitcoins every day. Okay, and they're all 24/7, working 24/7. And I'll just show you the snapshot of how these exchanges do look like. Right, this is the software for the exchanges. Wait a second. This is how one snapshot of the Bitcoin exchange looks like, the XMO, where you can buy and sell the bitcoins. Right. This is another one. Okay, and just see, you have all the values of different currencies, cryptocurrencies, and you have the candle bars which are there, which are very sensitive to any variation in the pricing, and it's all demand supply. And this is again a very active, Bitcoin exchange where you're trading bitcoins today. This is Bitmax. This is quite famous, right? Okay. Then other part you would like to know is the Bitcoin wallets. Now, where do you store all these bitcoins? And the place where you store bitcoins is in Bitcoin wallets. It's something like what you had, the Paytm wallets, what you have. But here, what you're putting is only the code, that 34-digit hash code, the alphanumeric hash code, which was there, is being, you're storing that. And the problem with this wallets is that if you forget it, you cannot retrieve anything. Okay, that bitcoins are all gone, so you cannot even work it out. So there are different kind of wallets which are there. There are desktop wallets, mobile wallets, cloud wallets, which exist. And this is the kind of Coinex is a wallet which is there where you can store Bitcoin. And right, this is the way you transact. Okay, so you have different Bitcoins which are there, and you can send and receive money like a normal wallet. Okay, and you can store the code in the wallet. It's either the external hard disk where you can store it. So this is called a offline or a cold wallet. Okay, so this is the one. Then is a paper wallet. People who try to forget. So these are the kind of paper wallets which are there. Okay, and something more. You have the Bitcoin ATMs which are existing all across the world now. So there are 7,000 plus ATMs in the world where you can transact using your Bitcoin. You can buy the Bitcoins from here. Okay. So this is again a Bitcoin wallet. This is again a different wallet for different things. So it's only for the Bitcoin Cash. It's for Bitcoin ATM, and then it's a Bitcoin. That's Ethereum. Right? Okay. So this is what is all about the Bitcoins, and they're all spread all across their different nodes, right? And now I will come to the part of the blockchain. So far so good. I hope any questions so far. I can take it on for 5 minutes, and then I can go to the blockchain. Anyone?
So you have put up the questions in the chat window, sir, regarding
Okay, I'll just
cryptocurrency.
I'll just take that.
G.
Okay, I will take quick questions, and then we'll jump over to the blockchain. So far so clear about it. Okay. So refer to the blockchain tutorial. So we'll discuss on it. I will tell you about it. Lots of questions. Okay, the question by Dilip. Application of blockchain technology in various domains. So practically, blockchain is going to be affecting all your domains per se. And to give you a feel of it, I'll be coming to that slide, but I can show it to you right away. Uh, it's going to affect every facet of your business. Yeah. So can you see this slide? Yeah. So practically what is going to happen is the blockchain is going to change whether it is your cross-border transactions of the bank, whether it's your payments which you're making in the banks or your SWIFT payments, your supply chain, that is going to change, your trade finance is going to change. Okay, how it's going to change, we can discuss on it. Even your voting can change. The way we are voting, we can have e-voting using the blockchain. Okay, your royalties can change. Your warranties, I can have it using the blockchain. Okay, customer acquisition, I can change. eKYC, your banks today, you're going to different banks and doing a KYC, like for example, you're going to ICICI for home loan, and then you're going to ICICI also for a house water loan and other things which are there. So every time you have to go through that KYC. So blockchain can give you the facility of eKYC, and just once you do the KYC, that is valid for all. Because for each KYC today they spend around 6 to 800 rupees. So you're saying saving such a huge cost. Then is your assets and logistics, asset tracking. So whatever is your asset which are being moving all across. Now, if you have that blockchain-based thing, then any tampering happening to that particular consignment can be identified. In supply chain, like for example, we have the containers which are coming from different countries. Now it takes 2 months for that paper of transactions to come from one country to another. That's a very longish process because it's to go from port to port, and the validation, signatures. But with the blockchain, you can do it with just a week or less than a week. You have the complete papers which are authenticated, right, to the destination, and then you can release the consignment. So it's all changing. Then is your real estate and property. So, say for example, today there's so much of problems in the land records. Okay, if you're implementing a blockchain, uh, because of the blockchain, nobody can manipulate that. Nobody can change things. So all the land record, all your property details which are there, they cannot be manipulated thereafter. Okay, that's another area where you can have the blockchain. Insurance, right? Right? If you have, say, for example, having insurance for the car or something, and there was an accident, now you have to really practically run behind those people to get your insurances done. Okay, get the insurance money. But here, if you're a blockchain based, you can actually self-generate a claim based on the validity, and you can get the claims very fast. Identity management, blockchain. So if it is identity management, nobody can change my identity. Nobody can change my data. So all those things are there. File storing and sharing. Whatever files or your thesis work which are you're writing today, people tend to manipulate. People try to steal the data. If you're blockchain based, people cannot do it. I spoke of example of the certificates of your college. If you want to give it, you cannot manipulate that. Your medical records cannot be manipulated. Okay, so your auditing cannot be changed. IoT. Say for example, you have a the medicine of cancer which comes from US, and practically to tell you the moment that temperature of that medicine, right, changes, that medicine is all fail. And that's what happens most of the time whenever we get the medicine. If the temperatures are not maintained, if the right kind of parameters are not maintained, most of the medicines what we get, especially of cancer, they're just like a water and nothing more than that. And there, if you put IoT sensors along with it, and if you put the blockchain, right, nobody can manipulate those kind of things. So it's a biggest advantage, and especially this works in Africa where they're selling so much of medicine into Africa, and people tend to manipulate and take away and do different things. If you have a blockchain-based system, you cannot do it. I told about the voting, right? E-voting system. Today you have so much of serpentine lines which are there all across for voting itself on a voting day. You don't prepare to do it. Put it on e-voting, put a portal, let it be open for 15 days to 1 month with your Aadhaar card, with a blockchain-based Aadhaar card. Go and vote. Nobody can duplicate that voting. Nobody can put a double vote onto it. Okay. Then is all your government systems, which are there, all your applications, your birth records, your degrees, your death certificates, your other driving license. Everything can be on a kind of blockchain. So blockchain, in a sense, it's can be used as a currency. It can be used as asset. It can be used as contracts, smart contracts. It can be used as data and peer-to-peer. So there are huge applications of blockchain which are there today. Right, Dr. Lee? Okay. Right. Uh, It is. It was by Umeshwari. It is immutable ledger of transactions. Yes, it is immutable. Uh, that's right. So the algorithm which is there is the elliptic curve cryptography. What we are using to break that code, and what we are doing is I've actually jumped that slides when I was trying to show, but then I will be discussing it later on. Uh, those are the ones which we use to have the public and the private key, right? So we can go on to it as a time permit. We'll discuss that. The other question is, what is the lock period of this e-money? How can it be in cash in local currency once minted? So practically, there is no lock period of the e-money. You can keep it for as much time you want, but every 4 years, the value of it goes one fourth, half, like not, of that value, not one fourth, half that value. That is one point of it. Secondly, in India, it is considered an illegal tender, so there is no connectivity between Indian banks. Otherwise, in 2018, before it was declared as illegal tender, you could practically, go to your bank and change that into the amount which was there. How to differentiate between cryptocurrency and block currency? So there is no terminology called block currency. It's a cryptocurrency, and I told you cryptocurrency is the transactions which are there for the proof of work, and the proof of stake or the transaction which enabled the complete cryptocurrency is called a blockchain. That's the underlying technology. Okay, so that's called the blockchain. So there's a difference between the blockchain and the cryptocurrency. Future of cryptocurrency, that's by Dr. Vasna. Yes, it is very promising as of now because it's exposed a lot of discussions all over the world. Facebook has come up with cryptocurrency called Libra, in which 125 companies have already registered to create that Libra. But there's a threat to the dollar where they said, the digital currency can dethrone on the fiat currency. So that's a kind of problem which is already there. But JP Morgan, Morgan Stanley, and other companies which are pretty good in finance, they have been saying that the digital currency has got a huge potential worldwide. Why Bitcoin is not valid in India? This was by the late Jetli in the month of when he actually had declared in 2018, to be very precise, when they had the budget, they made it illegal. And till now, it's not that the validity has not changed. It's still an illegal tender. Holding is not illegal, but trading is illegal. So we have to understand between trading and the holding part. Other question by Dr. Shikha is that, is this a parallel economy? Yes, in turn it's becoming almost a parallel economy. And today, the Bitcoin, in terms of the valuation today, they're almost $238 billion Bitcoin worth of digital currency, which is there all across. Can we say Bitcoin is an application of blockchain? I will say other way around. Blockchain is the product of the Bitcoin, and this is the hash code which is being given between two applications or between the algorithms. Okay, why does price of Bitcoin keep changing? The price of this by Dr. Anshu Agarwal, the price of Bitcoin is changing because it's purely based on demand supply. Moment the demand goes up, the price goes up. Okay, if the demand is lesser, people sell it, the price also comes straight down. So that's how it's a demand supply game which is there. Then is how can we relate this by Dr. Upasana? Yes, ma'am, you can do a lot of research work in blockchain, and like I told you, the applications which are there. If you just think of one application and start working on it, it will give you a lot of dividends. And for example, each facet of the life what we are doing, the blockchain has some work or the other. Okay, even your people are going for hotel booking, they are trying to use a blockchain. So, like when I told you initially that blockchain is going to change the way we work, the way we are today. Okay, it's a distributed ledger. It's a decentralized ledger. Okay, so if it is decentralized, if it is permissionless, how are we going to survive? So I'll come to those slides just in a couple of minutes. I'll tell that. But it's a really a wonderful work when I talk of research. And like I told him, what you're seeing the blockchain or it's in infancy. Okay, as per the Gartner also, it's a kind of a very promising technology. I don't say that we are going to see the blockchain immediately. It's the results we'll start seeing of blockchain somewhere 2024, 25, where we are actually seeing the blockchain. And it's going to have a combination. This technology will come in combination with IoT and AI. Okay, so all those things are kind of going to merge together to give you a very disruptive technology altogether. Dr. Dilip Kushwaha was that in banking, yes, in banking there are a lot of applications which are happening. eKYC, your trade finance, not your trade finance, so eKYC, your SWIFT transactions. Okay, those are the ones. Like for example, today if you have to do any transfer of money from one country to another, okay, and how do you transfer? You go to your bank and they transfer it. They have a SWIFT code, and based on it, they do it, and it takes time. Whereas using the blockchain, you can do it almost real time. That takes almost 25 minutes. It's not easy because you have to update all the blockchains, all the nodes all across, and then only you can, have the data which gets updated. So within 20-25 minutes, you can do the transaction of a SWIFT transaction also. Okay. So it's by Dr. Dolly. Is blockchain concept same as the database concept? I will say that it is add-on to the database. So it is encryptions which you are putting between two transactions. Okay, to validate those two transactions, right? So it works like that. So that is called a smart contract. So I'll just get onto that slide. So there's something called in a blockchain called smart contract, which are validating the transaction between one database to another database, or one uh, application to another application. As the consensus reached between this by Sanjay Deshmukh, the consensus reached between various parties for transaction. Yes, so just like this, There's something called a Benzathine, algorithm. Benzathine algorithm, I'll just share with you the slide. I think that will be good. Just a second. Sorry for jumping the slides, but I think that will make you a question. Yeah. So yeah, this is what practically is a consensus mechanism all about. The blockchain is based on an algorithm called Byzantine fault tolerance, and it says that if there are three generals and they have to practically do attack on the target, the the condition is that two generals have to say that we agree to do the attack, and the third general gives the way. That is two-thirds of the majority. So the nodes which are there, they're all along, they're all spread all over the world. Okay, those nodes, once they give the validation that the node is okay to be validated, the transaction is okay to be validated, they give the consensus, and that is what is the consensus mechanism. It works. Okay, it's by Umeshwari using different consensus algorithm. I think. See, there are other algorithms, but it's a Byzantine algorithm the best, which is being followed, and this is basically it gives you advantage of any cyber attack as well. So, Santosh Kumar, it's privacy for personal records. The private key compromise, loss of identity, is it secure? So, Santosh, if you can unmute yourself and you can ask this question, I'll be able to answer this.
No, sir.
Yeah, please.
Sir, regarding the privacies of the documents, etc., and private key compromise at the end of the receiver end,
Right.
is it that much
Yes,
secure?
yes, it is like this. If I got your point, like what you are storing at the end of the day, there is a private key only which you have. Okay, and
Right.
based on the private key, you secure those transactions. If you lose that private key, anybody can get into that records and you take the data, right? But you're losing it yourself. But Benzathine says that it's two-third majority, so that's different. This is that the privacy of the data is being lost if you're losing the key itself. So you're not left with anything.
Okay. Fine, sir.
Right. Yeah. And this is with Varsha. How blockchain can be used in medical domain for the diagnosis purpose? Yes. So while we're talking of the telemedicine, and we're also trying to keep all the health records digitally. Now, if you have to keep all the health records digitally, you have to have a kind of authentication between all the records which are there. Privacy of all the records, the secrecy of all the records which are there. Right? And I request to mute, please. Yeah. So all those medical records, right? Now you, in the times to come, you're not going to have your files where you had a printout of all the medical records taken to the doctor. So practically, if you have a blockchain-based, health system, which definitely is going to come in India, and there are a lot of people who are working on it. Okay, you can just go to the hospital and give your details, where based on your blockchain-based health records, he can analyze you, he can check you up, and give you the prescriptions and advice. So it is a major thing in medical domain as well. It's with the question by Dr. Dilip again. Can we replace physical money by virtual money completely? Uh, the answer is no, as of now. But digital currency is going to be the future. It's only, I will just put it that the time will tell as to how we are going to work. But countries like Malta, Estonia, Switzerland, they have replaced all their physical money transactions to the virtual currency transactions. So they have done it, but in India, it's a difficult situation. So it's only time will tell us as to how we are going to do that.
Sir, I would like to ask, what is decentralized finance? Like I have studied somewhere, for the blockchain purpose, we have to go for the decentralized finance. So how it is related to the currency conversions and all?
Decentralized finance,
Yes, sir.
and this wasn't see, but currency conversion. I'll just tell you, it's the blockchain, and you have to don't mix now. That Bitcoin, which I told you, was the other part. Now I'm coming to the blockchain part of it. So the currency conversion is purely the virtual currency which you mine, and you have a code for that, and it's got a value which is available on the share or on the markets, the trading markets. Based on that value, if the banks are permitted in India, and right now it is not. Earlier they were. If you go to a bank and that currency conversion of that point, like you trade your international currency, you get the money in your account. Okay, that was supposed to happen, but it is not the case,
Okay.
right?
Yes, sir. So
Okay,
it's totally different issue than blockchain,
pardon?
or it is totally separate than.
Yeah, it's a totally separate than the blockchain. I will be telling you about more on the blockchain, then it will clarify on your terms.
Okay.
And
Thank you, sir.
what the status of blockchain? India, Niti Aayog already has come up with a paper on the blockchain, and they have a vision for blockchain-based system. Your land record management, right, is the biggest user, which is going to be using the blockchain in a big way in the country. So they have set targets, and there's different states have started having the land record management of the blockchain. Telangana was the first state. West Bengal, they started having the birth certificates on the blockchain, right? So there is a lot of impetus on the blockchain itself in the country, and people are going for it. And like I told you, this technology is a slow moving but very strong, and there are a lot of startups in the blockchain, okay, which are there today, right? Manpreet Singh, as of now, GitHub using blockchain to maintain latest version control? No, uh, I'm not aware of it. They don't. I think so. They're not using that way, right? Okay, let me go back to my original slides now on this part of the thing, because now it will be much easier for me to tell you what the blockchain is all about once I've told you how it's being mined and how it's going to come up. Right? So blockchain is a big disruptor, like what we've been discussing as of now. Okay, and in times to come, you're going to see a lot of changes in yourself, a lot of the way you do the business, and it will change the way that you do business. And every CEO from every industry wants to know about the blockchain. So that's a very interesting topic. This I've already covered the origin of blockchain, so I will not touch upon this slide, but to again tell you, it was Satoshi Nakamoto was the person who started the blockchain altogether. So this is what the Bitcoin and blockchain was, the one which happened. So the underlying technology of the Bitcoin is a blockchain. So just I think right. So the peer-to-peer network of replicated databases, consensus-based databases. So that's how you're being using it. So you have to understand that Bitcoin is not a blockchain. So what I told you about Bitcoin, that was how you mine it. So you have to understand all that stuff, right? And what is a blockchain all about? So it allows untrusting parties with common interest to create a permanent, unchangeable, and transparent record of exchange and processing without relying on the central body. So these are points which I already brought in, that they are all a permanent record, they're transparent, the exchange of data, there is no central body which is there between them, and they don't rely on anyone, but still they are already there. Okay, and the term which is interchangeably being used is a blockchain or a distributed ledger. Okay, so just be careful about it, how a blockchain or a distributed ledger is being used. So this is a kind of ledger which is, we've all seen this kind of ledgers all over life most of the time. And what it has is that the record who owns what and when. So this is what is a record, and you can change it here if you want to change it. But when you come to the blockchain, the advantage is you cannot manipulate what you're writing in this block, what you're writing in this ledger. Okay, so what you have a centralized kind of network today, you have a decentralized kind of network today, and you have a distributed ledgers today. Okay, so the distributed ledgers are primarily, they are peer-to-peer. In this case, the first case, if we look at it on the slide here, the users are anonymous. Okay, and each user has a copy of the ledger. It participates in confirming transactions independently. So that's what they do. Okay. Second part of the distributed ledger, there are two parts of it. One, they are not anonymous; they know each other. Okay, and it can be within a company itself. So they know the nodes will be knowing each other, and the permission is required for the user to have a copy of ledger and participate in the transactions. Right. So this is how the different kind of ledgers do exist. So that is what we talk about there. There are public ledgers, there are private ledgers, right? And there are hybrid ledgers, okay, or the hybrid nodes. So the private is purely within your organization, and public is, it is open to all, okay, and it can be there in any part of the world. So blockchain is primarily tamper-proof. It's a shared ledger that records the transaction, and that can take place within the peer-to-peer networks. Okay? And you have the transactions that are confirmed and validated and are named and changed from the beginning of the chain to the most current. So like you saw the birds which are flying, so from first point to the last point, all of them are in, kind of chain. They are linked to each other. And that is why you have the name blockchain, right? So this we have already, I have told you that you have the blocks which are there, and all transactions within a certain period of time they are being filled in. We discussed on that, and all the blocks are linked together, and peer-to-peer, no central authority, and distributed. But to ensure the data integrity, that's very important. Okay, and this we have already done, so I will. So practically, what it does is that you have a block, okay, and you have a previous the code from the previous block. You have the hash. You have the nouns. These are the blocks, the numbers which are there, and you have the transactions which get entered, and then n number of transactions in a particular block. So those transactions make a single block, and then it's connected to the next block. And what is linking between one block and another? The block, and which are creating the chain. Okay, and these chains cannot be modified, or the hashes will no longer be valid. So if you're trying to change it, it won't you cannot change anything. I'll just show you one online kind of tool where you can see how a particular blockchain looks like, this kind of thing. Okay. So can you see the screen? Dr. Vishal, can you see the screen?
Yes, sir. Yes, sir. Fine.
Okay. So practically what I wanted to show you that while I was studying all the blocks one after the other, these are the blocks and they have a block number. Okay. These are the nouns which are the random numbers which get generated. And here are all the transactions which are being filled in. And this is all linked to the previous block and this hash code gets generated after this block. And you just see here, there's a block number 2 which has got again a random number. You got a previous block. This is the one which I was trying to show you, and there's a hash code which gets created. And similarly, it goes on to other blocks as well. Okay. Now this is how the block. So it goes on to endless. Now you just see if I try to change any value in this particular block, the block which are next are all not meeting the requirement. So they will not accept any change in the block. Okay. So what I want to tell you that these blocks are so interlinked that you cannot manipulate the data in between. Right. Similarly, here you have done it fine. It would from here on you will change the block and create it. But what is changing the moment I'm putting high is these hash figures. Just see these hash figures here. Okay. Right. Now, what I can do is I can manipulate it by an algorithm which is called mine-init, and it will change practically the nouns value, okay, to give me a value of my hash codes, right? And this is how I am trying to change it here, right? So practically I have now got the hash value which was on my other block earlier. And just see, I'll show it to you again. This is the blocks which are there, and it's got a nouns which is a random number. This has got a hash value, and we link up to the previous hash value. Okay. Now, if this hash value is not linked, there's a change in the block. Okay. If I manipulate here, okay, now this hash value are all going to change. Okay. But what I can do is I'm going to do a process of mining, try and work out a noun which works, and this hash value and this hash value, I'll try to bring it at the same level. And so that I am able to put my block, but then I have to do it for all others. So when we say the blockchain is immutable, or you can do a double spend, or no changes can be done in between, this is how the hash values cannot be manipulated altogether, right? Right. Now, we brought out that it's a public ledger of all the Bitcoin transactions that have never been executed. Okay, that have ever been executed, and it's a type of database that takes a number of records and put them in a block. Okay. So, Dr. Dolly, your question was like it's the same thing which I'm trying to say here. So there are a number of databases, there are a number of entries which practically make it a kind of a block, and you're then collating that particular block and publishing it. And once you publish it, it's a consensus mechanism which works, and everybody along in a distributed environment and different node, they validate it. So these are a sequence of electronic files in which entry-linked transactions is gathered and condensed. Okay. And some of the technology which are being used, I'll just try and tell you that as well. So it's a distributed database, and that are time-stamped. There are cryptographic tokens which are publicly PKI based. There's a public and a private key. You're using the cryptographic hash algorithms, kind of a digital signature for text strings or data files. You have peer-to-peer architecture, and every node is a client and server. So that's what it has. And you have a consensus mechanism and the agreement on what event and transactions happened and when and collectively endorsed them. So that's what you do. And the programming languages, you have the Solidity, you have C++, you have Java. So all those kind of languages are being used, and different things are being available today. And there are lots and lots versions of different blockchains also available. Some of them are private bitcoins, public bitcoins, which are available in the market, right? Okay. And then, the problems which are addressed through blockchain is the double spending, which will be prevented as the nodes will reject it immediately and communicate it to them. Then second is due to aggression of transactions by different miners, two new blocks can be formed following the one earlier block. So that's another kind of problem, and it's called a fork. So there's always a fork which gets created, and each fork it can have a different pace, one longer, one shorter, and there are two kind of fork. One is a hard fork, and one is a soft fork. So these are the kind of models which are there, and if you have read through the forks, there were the Bitcoin Cash and the Bitcoin. They had a hard fork which happened last year, a couple of years back, and they went on to a different direction altogether. And the Byzantine general's column, which I told you, of two-third nodes, and the simple attack can be avoided and inherently can be addressed. And no one miner can supersede the majority unless he exceptionally has a large computing power. So it's controlling, and against any cyber attack that way. So you have to have really a large kind of computing power today. And this is how a blockchain works. So we spoke of the Bitcoin. So here you have different nodes, okay, and there are different blocks which are processed. There are the mining process. We saw how the mining is taking place, and the blocks are validated by the network and added to the blockchain. Okay, so all the you see they are all blocks which get validated here, and they're there. And you have this. This is what is your key, which we've been talking of, the hash key between each blockchain, each block. Okay, and they are all verified, they're timestamped, and all the transactions are there in each block. Okay, and they're all cryptographically signed and sent to the network node. So you have different nodes which gets created, which are there at the bottom, one after the other. Okay, so this is how practically a blockchain works all over, and you'll be able to understand it better now because once you saw that how the Bitcoin was mined and how it works, so now you'll be able to correlate that what is the computing power which is being used by each of the kind of node which is there. Okay. And there are three levels of blockchain. One is the storage of digital records. You're exchanging digital assets, that's the tokens in between, and executing smart contracts. So I was telling you about the smart contract and how the smart contract. I'll just briefly tell you how it works. And this is how the nodes look like. And while I was telling the example on the internet itself, you have the block headers which are there. You have different timestamps, the degree of difficulty which is there, the code and the transactions which gets included in each block. So each block has got all those details, right, which are already existing, and they are referenced to the previous header as well. Okay, referenced by the previous header. So that is how these blocks are all interlinked, right? And some of the terminologies what are being used, there's a block depth, there's a block height. It tells you number of block height, gives you number of transactions which are there in each block. What is the block depth is another definition which gives the details of the depth of the block of interest from the latest block. And as we go on from one block to another, say for example, if you look at from the lower to the higher, the degree of difficulty of mining those blocks is getting difficult. Okay, the deeper a particular block is from the latest block, the more difficult it is to alter the transactions. And that's what I have tried to show you when I, I tried to change the text in any of the block which was deeper. You can change it, okay? And but it doesn't mean that you cannot alter the blocks, right? But when I showed you the illustration of how you can manipulate by the mining kind of thing, so you could still do it. But this makes all the blocks immutable, and you cannot modify once those blocks are created. Right? This I've already, I think, brought in different perspective. These are the kind of blocks which are there and the distributed ledgers. And whatever transactions which happen, right, and different blocks which are there. So all that get updated in different nodes. So these are the nodes 1, 2, 3, 4. And as and when there's a transaction which takes place, the node gets updated, and there's a consensus which happens. Okay, and that's how the block information is passed from one node to another. Okay, so that's how the different nodes are updated. Right. This I think spoken of it. And what is linking between the blocks is a proof of work. And this is what is called the mining. So once you mine, you get the proof of work, and that is what it's a reward what you get, or that's a Bitcoin. Okay. These are the different blockchains, very common and the famous ones, which are being existing today. It's a hyperledger, the multi-chain, the list, open chain, Ethereum, Neo, OS, and the one which I've written is a Bitcoin. This is my creation of a blockchain as a service. Right. And here I've tried to give you a snapshot of how a different blockchain and when they came into being, what are language support they're using, what are the consensus mechanism they're using, and what is the size of their kind of team, what are the funds which are being raised, what's the market cap which is there. So each one of them have got their own kind of advantages, disadvantages. Based on the degree of difficulty, they have the valuation in the market. Okay, on this blockchain, and they're all public blockchains. So I'm not talking about some of the private blockchains which are there. So public blockchains are the ones which are available openly for people to mine, right? And there in the blockchain I spoke earlier, there are different kind of things. One is the private and permission. Okay, if that is the one which will work in the case of the banks, it is public and permission. There's a kind of a blockchain which is called Ripple. It's for the global transactions. And then you have a kind of a blockchain which is public and permissionless. And that is the Bitcoin currency. Okay. So I think this should be able to give you a kind of feel of how a different kind of blockchains do exist today. And today what you have in banks, for example, is your traditional personal bank accounts. Okay, that's the ledgers which you have. So those are the ones, the traditional way of ledgers, and then you have the public and the private. So that's what you are able to have it. Okay, right. So this I already brought in. So intercompany, you have intra-company within a company itself. You have a private and permission blockchain. So you have the scattered application landscape of single institution, corporation, available. Then you have the intercompany space, that two different companies. So you have the public or private, both of them can exist, and this ecosystem of consortium is basically sharing blockchain utility platform. So that is the one you can use it, and then you have end user space. So that is end user space is the public permissionless blockchain, and it renders the role of trusted third party, obsolete kind of thing. And when we say Why do you require a blockchain, and does everything require a blockchain? That's a question which always comes, and this is where I've tried to put across the kind of pain points. You can put a blockchain where there is an absence of trust, right? Where there is an absence of security. There are multiple databases referencing common object. Okay, you have a reconciliation elimination. You have standardization and harmonization problems. Yeah, you have the automation code as a law. That's a smart contract which are required. And you have reduced systemic risk. So these are the places where you can, use blockchain very effectively, right? So it will give you a lot of advantages. Other places also you can use the blockchain, and it gives you fantastic, application. So it gives you transparency and anonymity, and data is available to all participants. Like I told you, if you have a node which you have created, right? So starting from the Genesis block to the latest node, you have the complete data which gets available. Okay, and the users are anonymous in this. Okay. Then you have the immutability. Data is stored forever in the blockchain and cannot be altered. So whatever the data is there, it's going to be there. And it's the decentralized consensus, right? So it ensures consensus within a decentralized network. Okay. So what it gives you for the next generation of collected world, it gives you an ecosystem of collaborated platform. It gives you a synchronous and real-time processes which are available. It gives you interconnected blockchain, and it gives you global value chains. Right? So it's kind of an advantage over loosely coupled system. Your asynchronous offline systems, it gives standalone blockchains or your local value blockchains. It's giving advantage over all of them, right? And what are the four components which we talk of very importantly on a blockchain? Okay, we talk of shared ledgers, we talk of smart contracts, we talk of consensus, we talk of the privacy. Okay, and when we talk of the shared ledgers, these ledgers are append only. Okay, they are distributed systems of record. They are shared across the business network. The second part, which is more important, is the business terms which are embedded in transaction, like I was telling you about the example of insurance. And these are executed with the transaction. Say, for example, you have the SAP application, and if you have a blockchain-based SAP application, so that application will trigger, the next step will trigger only when it meets the smart contract, kind of requirement. Then you have the consensus, that is the proof of stake and the proof of work. Okay, and all parties that agree to the transaction, and that's how you have a consensus mechanism built into it. And you have the privacy, where it ensures the visibility, transactions security, authentication, and all these transactions are verifiable. Okay, so this is how it's giving you a broader participation, lower cost, and increased efficiency. Okay, this I have discussed. And some of the benefits, it is empowering users, it gives process integrity, it gives a high data quality, it's giving you durability, reliability, and longevity, okay, of any process which is there, transparency and immutability, and disintermediation and trustless exchange of data. Okay. What advantages? It's a time reduction, ecosystem simplification, it gives a cost reduction of any process, and also a smart contract what you have. Okay. Now, what practically is a smart contract? That's what I will just touch upon. This is a program that runs on the blockchain and has a correct execution enforced by the consensus network. So it's a kind of a trigger which gets activated, and it's embedded in your SAP database. And it enables trustless financial services like loan, micropayments, and you can actually get rid of intermediaries, okay, and the third parties because of this. So smart contract plays a major role when we talk about the blockchain. Okay, this is a pre-written code, and their distribution is like they're stored and replicated on a distributed storage platform, and the execution is done by a network of computers. Okay, and they can result in the ledger update. That's what the particular transaction will trigger only it meets a condition. So that's how it practically happens. And this is a protocol which is so important for executing any contract. So if you look on it, there's a direct synchronous transaction which takes place, and then you have a transaction with the arbitrator in between. Right now, the smart contract practically gives you an advantage that you don't require to have an arbitrator. You can just go without an arbitrator and execute any contract, right, without any intermediary. Okay, so that is how it gives you advantage of uh, facilitating any transaction. This is kind of code which is there, the smart contract. Yeah, anything, please? Anything? Okay. So the advantage of the smart contract versus the traditional contract is that a normal contract, if you are trying to execute, it takes 1 to 3 days to execute, whereas a smart contract you are able to execute within minutes. It's a mutual remittance. Here you are doing the automatic remittance. So the trigger goes off the moment you meet the condition. Uh, Otherwise, in a normal traditional way, you have to have an escrow which is necessary. In this case, you don't have any escrow, in between any transaction. Uh, Traditional are expensive. Here, fraction of cost for doing any transaction. You have physical presence. The signatures are the kind of bit signatures what you're doing. And in case of your smart contract, you're having a virtual presence. That's a digital signatures. And lawyers may not be necessary in case of the smart contract. It's just that that gets executed. Whereas in the normal case, you have lawyers which are required. Okay. This is about the Byzantine fault tolerant, which I told you that two-thirds of the journals have to agree to any kind of attack, and this is advantage that 51% of the nodes, if you're overtaking them, then only you can cause a damage to any network. Otherwise, you cannot cause any damage to the network. This damage. So I will just touch upon some of the points of the normal from your education point of view where you can utilize it. Uh, Today, what you're finding is that the institutional staff can change the grades after the fact. Student can compromise the database. Data can always be changed. It can be hacked. That's one of the problem what you're facing. Data can be deleted, right? It can be inevident through loss, your accidents, your calamity, anything which is there, right? The students not given access to metrics held on them, so the institution can prevent the access. Today, that's what is the condition, and you have a dispute over ownership of intellectual property rights. Okay, like you have the thesis which are being, people are copying and stealing the data and trying to do the plagiarism and work on those theses and telling them those theses are ours. And if it is blockchain based, that will be the case which will be overcome. And institution can put conditions on access. So institutions can charge for verifying data. That's we can have it, and digital data can only be available through proprietary system. Okay. And an institution can use data in an unauthorized manner. Right. So these are some of the challenges which are facing day in and day out today in your institution as well. Whereas with the kind of blockchain, what you can try to do, one, you can have your e-certificates, right? All the certificates what you're giving to the students can be based on the private key and the public key, and the digital certificate can be signed and given to them. Okay. and that cannot be manipulated by any student, and it can be verified in any accreditation agency or any organization. So once a certificate is generated, it is kind of a stamp which gets embedded into it. So these are the kind of you know uh, certificates which gets generated. You have the hash key which is embedded into it. So you have the receipt of the hash key and the recipient and the receipt and the public key which is available. So this is the kind of certificates which can be created for any education institution, right? So there already in Europe there are institutes which they have implemented these kind of certificates. They have done the pilot and they are going ahead with it. Okay, and this can be trusted using any mobile application if it is blockchain. So you don't require to have any physical certificates to be created and given to anyone. So all the digital credentials can be put in one place, and you can show it, and they all trust it, right? So the European Union is quite active. They have gone in for these kind of certifications, right? So this is the kind of certificate verifications which do happen, and if you come to know based on the transaction whether this certificate is verified or not. Okay, so where are other places it can disrupt your education industry? It can disrupt the issue and recognition of credentials. It can help you in management of intellectual property rights. It can help you in payment and smart contracts, and it can help you in identity management. So these are the some areas which I could figure out where in academics in particular, it can help in a big way. Today where we are struggling for the credentials, the IPR, the smart contract, and payments, and the identity, right? So with this, I will just cover up one more point. You know, while we speak on the blockchain, if you have to implement the blockchain in any industry or any organization, so you cannot let your data go out, you know, to all the public ledgers to update. So there I came up with the concept of blockchain as a service. So uh, basically, this was all the disputed ledgers of different application in any organization can come onto a single platform, and I could make them plug and play. Okay, so this is what we have been able to do it, and we have coordinated tested mode, and I can have different application, whether it's a defense application or e-voting or warranty or loyalties, all those applications I can run over the blockchain as a service. So it's kind of a platform which uses a smart contract, and all the participants who are there, they can manage the transactions themselves. So that is a kind of a very plug and play tool which we've been able to create. Okay. So this is what I wanted to tell you about, and I've finished with it. Should you have any questions, we can have a kind of run on that questions as well.
I request to all the participants, if you have any query, any doubt, you can put up in the chat box, please.
Yeah. So I'll take up all the questions.
Yes, sir.
So, Umeshwari, what is a double spending? Double spending is that each hash key has got its uniqueness, right? And once you use that hash key, say for example, that particular hash key for one transaction, now it gets updated, right? And that transaction, if you try to do it again, it won't permit it. So in the ledgers. So once you do that double spending, it doesn't permit you to do that kind of a double spending. So one hash key can be used only once for that particular kind of transaction. So this is what is a double spending all about. uh, by Dr. Sikha. What do I mean by blocks are growing at a different pace? When I say blocks are growing at a different pace, is that uh, to create a block, right? You have to have number of transactions which are to be there. Generally, the number of transactions which happen in a block. Once that we say that these are the number of transactions which are taken place, we seal that block. We say this block is full, and we give it a number, the block height, the hash code, the previous block, the next block, and all those stuff. Now, as and when the transactions happen, there's a time delay. Number one point. That is one which we have to, the different pace is what I was referring to. That is one. Secondly, in case of any transaction, say for example, a transaction in a bank. Now, if I have to do, if it is a public ledger, now if you're doing a transaction of say ICICI Bank, and if you're a public ledger, that means it has to be updated in all the ledgers which are there all across 15,000 notes. To update those nodes, it will take some time, right? And once that nodes are updated, and every node has to give a confirmation that my node is updated, then it gives a consensus that we have done with our updation, right? They give the confirmation that the node has been complete, and that's how it goes to the next node, next block, right? So that is how the pace of the block generation is concerned. So we just can't say that it's going to be classic 30 minutes with the block size. So we are not going with that mathematics. It's the power which has been used by different nodes to generate, different algorithm. To make the codes. Any example of Manpreet, any example of unidentified e-money? So, if you can elaborate this question, this is a very interesting question. But what would you like to know? I'll be able to tell you then.
Yes, sir. Thank you so much, sir. Sir, in text we have studied that there are like four broad categories of e-money. Two, we say that one is online money, one is offline money, and another is identified. There is anonymous online e-money, anonymous e-money, right? So if we
Right.
take permutation and combination, so we have four categories of e-money.
Okay.
One is identified online e-money, identified offline e-money, and another is anonymous offline e-money, anonymous online e-money. And when I
Right.
say online e-money, it means banks are involved.
Right.
When I say offline, it means banks are not involved.
Okay.
And when I said it's identified, that trail is there, that how that money is going to be spent in the market. When I say unidentified, it means there is no trail, like cash. Like if
Right.
we have some money from the bank, then there is a trail.
Yeah.
But when we go to
So,
the market, when we buy some fruit, we buy some vegetables, there is no trail.
okay, I'll just tell you about this particular thing. In case of the cryptocurrency, what happens is, the cryptocurrency is called a pseudonymous. It is not anonymous. Pseudonymous means that I can still find out who is the owner of that wallet, who is the owner of that hash code with that Bitcoin is connected to, and what is the trail of that money. If that money is being given to ISIS, for example, okay, it will have gone from one wallet to another, to another, to another, to another. Okay. For people, it may be anonymous, but for a law enforcement agency, it is pseudo-anonymous. That means I can still find the trail of the complete, transactions of the cryptocurrency, right? So it is pseudo-anonymous. So that is how the currency works in case of the bitcoins or the other cryptocurrencies are concerned. I hope I answered your question. Manpreet? Okay. So another question by Manpreet is, what all blockchain-based softwares are available in market and that can be used at institution level? See, there are a lot of startups which are working on different applications of the blockchain for education purposes itself. and the n number of them. If you try and search on the internet, there are large number of them which are available. I told you about the use cases which are pertaining to the education institute. I think that will work pretty good. Right, and it's by Ramu where it's being implemented in the academic institution. I told you the example in European Union. There are some of the universities they already try to adopt blockchain, especially for the certificate in issuance, all the degree issuance which are there. So they have started to do that. And this is a food for thought what I gave you, because I myself have made a blockchain as a service platform. So that's a food for thought for all of you, that there's a lot of application of blockchain in academics. So you can now, since you know what a blockchain is all about, you can utilize those, through your researchers, through the students. You can try and get into these kind of developing those for your causes. All right, so you can do that. How blockchain can be used in the payment gateways? Yes, by Sanjay Deshmukh. Yes, I will give you the example of the SWIFT transactions. Right now, in the case of the SWIFT transaction, now is a normal, is a traditional transactions. What you do, you give it to your bank, they give you a SWIFT code. Based on the SWIFT code, they transfer it to the other bank. They get a confirmation, and then the money is being transferred. Whatever time it takes. Whereas in the case of the online transaction with a blockchain, now I can be able to trace that transaction if I'm doing it online. So that's a bigger advantage what I'm getting, and the transaction will be much faster. ICICI Bank has gone in for a kind of pilot for doing a SWIFT transaction. So they've already gone in for it, and it's in times to come they'll all be on the blockchain based transactions, especially for the international transactions. Right. Then there's how blockchain can be used in different payment gateways. Yes, again, you see the blockchain it's basically that smart contract which I have been talking of again and again. That gets triggered, okay, and that is the one which is going to be there always, okay, which triggers the kind of transaction, and it keeps a note of the transaction as and when you are doing it. Say, for example, if you have Paytm wallet. Okay, and if it is a blockchain-based Paytm wallet, today you do a transaction, you don't know how the transaction. It's just kind of a database which is being there and it's being updated entry after entry. Now, if I have a blockchain-based Paytm wallet, right, all my transactions will get registered. Nobody can manipulate it. Nobody can touch that particular transactions. So nothing is going to go wrong. So different gateways can use this particular blockchain in a very effective manner. Okay. It's by Dr. Anamika. Bitcoins are bypassing the government control. Is it okay to decentralize the control? So, ma'am, there are a lot of thought process which are being on in India as well. They wanted to do one currency called Lakshmi, then they stopped it, and because they felt that it is a the threat to the Indian currency, and because it is decentralized, there is no control. But in times to come, there will be some form of currency which will definitely go as a digital currency, because that's the next line of we are going to be in blockchain, and the digital currency is going to be coming in a year, 2 year, 3 years, whatever time. It's going to be there. That's the reality. This is by Dr. Vishal. There are lots of research areas for blockchain. If you can do one research area which is pretty interesting, that is going for a blockchain as a service. So it's a kind of a platform. It's a kind of a systemic research which you can do it. And blockchain as a service is one thing which is so important today, right? And you can implement, say, for example, in your college itself. You want to have your attendance system, you have your marking system, you have so many databases which are there. Okay, you can put a blockchain as a service in your college, because today, if you look at it, some may be running on DB3, some may be on Oracle, some may be on SAP. And if you think are you going to change all these databases? My answer is no. Don't change it. You need to interoperate all these databases in times to come. How you can make them interoperable? You have a blockchain, okay? And this is the one I wanted to show you because this is the one which I created and we worked on it quite interestingly. This is the platform. So this is the base. You think this is your college, okay? This is your infrastructure which is there, and this is all the VMs, all the applications in the college. These are all the services which are there, and sorry, these are all the VMs. These are all the services which you want to give it, and this is all the actions which you want to do it. It will be a modular, layered, interoperable, and it will be a legacy system compliant. So, and it's kind of replicated. You can replicate it to different companies, different organizations. You can make it as a financial model to sell it as well. So you can do that. Yes, the question by Umeshri, Hyperledger and Ethereum are different. Yes, they are different. A Hyperledger is a capability of a private ledger or a private blockchain, right? So Ethereum is a public blockchain. So there are different kind of blockchains, and they have, like I told you, I showed you that slide of the blockchain where they have kind of the differences. I'll just show it to you again. I think you missed it. Yeah. So these are the famous ones. So these are the names which are given all across: Qtum, Ethereum, Neo, Vanchain, Lisk, Arc, right? And these are the consensus mechanism which are so different from for all of them. They use different, and some are kind of private, some are public. They have different kind of technology, sorry, the software support which are they working on. Like Qtum is working on Solidity, Ethereum on Solidity, Neo on the Java Shop, C Sharp, JavaScript, .NET, and then you have the Solidity and different kind of things. So they're all working on a different concept, and they also have different kind of smart contracts which gets implemented, right? So that is how they are, being structured. And difference of the architecture, different kind of programming languages that make it, function in a very different manner. Okay. Please put some focus on how blockchain and social citizenship will be linked. So in times to come, I'll just tell you that this is by Dr. Anshu Agarwal. We are talking of fake news. We talk of deep fakes, and we do talk of kind of on the social media, like especially Facebook and all. They're trying to come in a big way with blockchain altogether. And today, like any criminal who's there, he tries to put a fake photograph or a kind of a mock photograph, and then he gets away with it. But with a blockchain, he will not be able to do it. He gets registered in the database, right? So those kind of things will be very less today. Like for example, you are seeing on Twitter itself, there's so many handles which are originating from Pakistan, and they're trying to motivate or to change our mindset, psychology of Indians against all the bads of different parts of the country, and they are operating from Pakistan. But with the blockchain, and what they do is they post and they vanish. So after a few days, you don't find that post anywhere. You don't find that user anywhere. But with the blockchain, now he cannot do that. He will get properly logged into the database. Okay. Then is
Now I think, sir, we can take a offline query if anyone has.
Definitely. I'll take that offline
Yes.
query.
So you can please share the details again. That will be
Yeah.
helpful for the participants, sir.
I'll share it again. I'll do
Yes, sir,
that.
please.
So any other query, if you have, do ping me. There's no. It will be a pleasure to interact with you all. That's it, and I'll also give you my LinkedIn ID so that. Yeah, I've shared that. Right. Perfect. Any other question? Anyone? Any pressing questions? If you have, you can always ask me. Otherwise, I'm available. I just shared my contact details. It will be a pleasure to meet you all. Right. So thank you, Dr. Vishal.
Just 1 minute, sir. I'm coming, sir. I will take you 1 minute more, sir.
Okay, perfect.
Sir, it is great privilege to have you with us in the 1 week faculty development program. And this is a small certificate from all of us for your giving time. But 4 hours, I know you have a very busy schedule.
It's a pleasure always, and it was very nice to be with you all. And
Yes, sir.
it makes insightful for you to get into blockchain for your institutes. It will be
Yes.
pretty good.
Yes, sir. I will discuss with Hoda, sir, and we'll plan a few sessions for our students also with you
Right.
because they are the actual learners. We faculty are not a good learner, but students are a good learners who can develop something.
That's right.
Yes,
That's
sir.
right. And
So,
blockchain is one area where there's can be a lot of research work today, and put together with IoT and AI.
yes, sir. Yes, sir.
Blockchain is a very big solution kind of base for all these technologies.
G, sir. Okay. Thank you very much, sir.
Thank you very much, sir. Thank you very much for your facilitation,
Both the
and thank
sessions
you,
were
Huda, sir.
wonderful.
Oh, thank
Both the
you.
sessions.
This is the replica of the actual certification in physical mode.
Thank you, sir. Thank you very much.
Look, this team slowly is innovating.
Yes, sir. It is innovating, sir.
And thank you so much for
Thank you
having
very
me.
much. It's a pleasure, sir. It was my pleasure. Thank you very much, sir. Namaskar, sir. Bye bye, and bye. All the participants, stay safe. Bye bye.
Thank you, sir.
Yeah, bye.
Bye, sir. Thank you, sir.
Thank you,
Thank you,
ma'am.
sir.
Thank you very much. Thank you.
Sir, thank you.
I request you all to join by 10:45 a.m. on tomorrow.
Okay, sir.
Thank
Okay,
you.
sir. Thank
Thank
you.
you very much to all. Thank you.
Thank you, Vishal, sir.
Okay, sir. Thank you, Vishal, sir.
Thank you, sir. Thank you.
Thank you, Dr. Vishal. Thank you so much.
Also,
Adak sahab, how are you? विशाल जी
आंटी कैसे हो सर? हेलो,
हेलो
आवाज आ रही है सर?
आर यू हियरिंग मी?
हेलो,